students, in our previous lecture we discussed about what is physics. So the definition of physics is basically if you connect yourself with the laws of nature, basically with yourself to the surroundings, or in other ways, if you connect yourself with the reality, the magic will be created, right? And physics will no longer be a difficult subject for you, right? So we discussed about motion and rest. Now the definition of anybody to be at rest and anybody to be on motion is very simple. So for understanding rest and motion, we take a reference point, right? And the time frame. Now reference point is that point which is known as origin, or it is that point from where the distance or the position of anybody is measured, right? So let's suppose this point O, which is basically the origin and the reference point. Now there is a body which is presently at point A at time t is equal to 0. Now time t is equal to 0 specifies that this is the time from where the calculation has been started, right? There may be various times, there may be various time slots, but we are least bothered about it. What exactly we are doing? We are going to measure the time from this particular point, right? So that particular time is known as time t is equal to 0, right? Now what we have noticed that the position of this particular body at time t is equal to 0 was OA. So OA will denote the position vector of initial position of anybody, right? Now after t is equal to t time, we saw that the body was still at point A, means there was no any change in the position of this particular body. So we will conclude that the body was at rest, correct? Now this was case 1. Now let's talk about case 2. Now in case 2, what we have noticed is that the body displaced from point A to point B, right? And the position vector will be joining the line from the reference point to the next point, right? So OB will be the next position vector, correct? Now if some people have some confusion that what is a position vector? Position vector is nothing but a vector which joins any position from the reference point. Means if we join the reference point to any position, so this direction will be and the magnitude will be together will denote the position vector, right? Now when we will discuss about scalar and vector, then these parameters must be clear, right? To understand, now let's talk about the second case again, that initially the body was at point A and finally the body came to point B, right? So OA and OB are the position vectors, right? But AB is the displacement of this body from point A to point B, right? Now let's suppose finally from point B the body reached to point C, right? Now the body has reached to point C, right? Now again what do we have to do? We need to join this vector. Yes. Now OC is the final position vector. OC is the final position vector of this body, right? So now what have we noticed? That at time t is equal to 0, the body was initially at point A, then at time t is equal to t, the body came to point B, and finally it reached at time t is equal to t dash at point C, right? So here the distances that were covered by the body is from A to B, AB, and then from B to C, BC, right? So the distance, basically this is the total distance covered by the body is equal to AB plus BC, right? This is the total distance covered by the body during the complete journey, right? But on this other side, if we talk about what is the displacement, what is the displacement covered by the body, right? Now, this displacement will be if you join point A, which is the initial point, to the final point, it is this. Means it will be AC, vector AC, correct? This is the displacement, right? Now, when we put an arrow mark on AC, so what does it mean? It means that AC, the magnitude of this length with the direction also, right? This is the direction part. So AC has both. What are the both? The magnitude and of course the direction, right? So that's why AC is a vector, which is known as displacement. But when we have to talk about the distance covered by the body during this complete journey, so it will be AB plus BC, only the magnitudes. Now here the direction doesn't have any role, right? Now if you have any confusion regarding the direction and magnitude, so let's discuss in brief that physical quantities. Physical quantities. Now physical quantities means whatever quantities we study in physics, they have been divided into two categories. First is a scalar and other is vector, right? Now what are scalars? Now scalars are those which have only magnitude, only magnitude, right? And vectors are those which has both magnitude and direction. Correct? Means what we can conclude is vector quantities are those quantities in which you will get both magnitude and direction. On the other hand, scalar quantities are only those quantities in which we have only magnitude, not direction, right? So here we can say no direction, right? Now examples for scalar, we have speed, right? Time, right? Then distance. Whereas in vector quantities we have velocity, then acceleration, force, right? Hope the points are clear, right? Now in our next lecture we will discuss about what is speed, what is velocity, what is acceleration, and of course the scalar and vector quantities, right, in detail. Till then, thank you, bye bye, take care.